Hey everyone, welcome back to our channel. Today, we're diving into one of the most powerful concepts in programming, and that is recursion in Python. Whether you're a beginner or an experienced developer, understanding recursion is essential for writing efficient and elegant code. So let's jump right in. Recursion is a technique where a function calls itself in order to solve a problem. It's like a Russian nesting doll, where each doll contains a smaller doll inside. Similarly, in recursion, a problem is broken down into smaller, more manageable subproblems until a base case is reached. Let's take a look at a classic example, the factorial function. The factorial of a non-negative integer n, denoted as n!, is the product of all positive integers less than or equal to n. Here's the code example. So here we defined a function called factorial, which takes an integer n. Now let's move on to the logic. If n is equal to 0, or n is equal to 1, return 1. Else, return n multiply by factorial of n minus 1. Let's call that function factorial. Give it a positive integer, let's say 5. Let's run this. As you can see, it prints 120. Since n is not 0, the function enters the else block and calculates 5 multiplied by factorial of 4. Now, it needs to calculate factorial of 4. Again, 4 multiplied by factorial of 3 will be calculate. This continues until factorial of 1 is calculated, which returns 1. Then, the values are propagated back up the recursion chain. Now, let's see recursion in action with a practical example. Suppose we want to compute the Fibonacci sequence, where each number is the sum of the two preceding ones. The sequence begins like this. Here is a diagram that illustrates the Fibonacci sequence. In this diagram, each number is the sum of the two numbers above it. The sequence grows rapidly, and the numbers become increasingly large. Now let's move on to the code. Here we have a function called Fibo which takes number of terms as an argument. If n is less than or equal to 1, return n. Else, return Fibo of n minus 1 plus Fibo of n minus 2. N terms, which means number of terms, equals, let's say 12. If n terms is less than or equal to 0, print, please, enter a positive integer. Else, here I will iterate each number and pass them to Fibo function. For I in range n terms, print Fibo of I. And there you have it. Let's run this. As you can see, it prints the sequence of Fibonacci series of range of 12. Let's print them in a single line. So here I will write end equals space. Here you can see it prints the sequence in a single line, which is more easy to read and understand. Now let's understand the code. The function checks if the input n is less than or equal to 1. If n is 0 or 1, it returns n itself. These are the base cases of the recursion because the Fibonacci sequence starts with 0 and 1. If the input n is greater than 1, the function enters the else block. It calculates the nth Fibonacci number by recursively calling Fibo, n-1, and Fibo, n-2, and adding them together. This is where the recursion occurs, breaking down the problem into smaller subproblems until the base cases are reached. The recursion continues until it reaches one of the base cases, n equals 1. Once the base cases are reached, the recursion stops, and the values are propagated back up the recursion chain. Next, we defined a variable called n terms which takes the number of terms we want in the Fibonacci sequence. If the number of terms is a non-positive integer, the code prints a message asking for a positive integer. Otherwise, the code proceeds to generate and print the Fibonacci sequence. The for loop iterates n terms times. In each iteration, I takes on values from 0 to number of terms. Within each iteration of the loop, Fibo of I is called to calculate the current Fibonacci number. Remember, Fibo is the recursive function defined earlier. So for each value of I, it computes the corresponding Fibonacci number. The calculated Fibonacci number is then printed. The end equals space parameter ensures that the numbers are printed on the same line with a space between them. Let's illustrate this with an example. Suppose the user inputs number of terms, 5. The loop will iterate 5 times, from 0 to 4. Here's what happens in each iteration. When Fibo0 is called, which returns 0. So the output will be 0. When Fibo1 is called, which returns 1. So the output will be 1. When Fibo2 is called, which calls Fibo1 and Fibo0 recursively and returns their sum, 1. So the output will be 1. When Fibo3 is called, which calls Fibo2 and Fibo1 recursively and returns their sum, 2. So the output will be 2. When Fibo4 is called, which calls Fibo3 and Fibo2 recursively and returns their sum, 3. So the output will be 3. Thus, the printed Fibonacci sequence will be 0 1 1 2 3. As powerful as recursion is, it's important to use it wisely to avoid Stack Overflow errors. Always ensure that your recursive functions have a clear base case and terminate properly. Additionally, optimize your code by storing intermediate results to avoid redundant computations. And there you have it, folks. Recursion demystified in Python. Remember, practice makes perfect. So don't hesitate to try out recursion in your own projects. If you found this video helpful and learned something new, don't forget to give it a thumbs up and subscribe to our channel for more such tutorials. Thanks for watching.